Thanks for hanging through the proof. All right, let's get this thing isolated. And that'll be what the formula we written as. So I have to subtract that.
Yeah.
So now you go, all right, the integral of f g prime of x dx is equal to, here it comes, this is gonna be our formula. This is gonna be our formula. We're gonna take that and subtract this. All right, here it is. It's gonna be f g of x, subtract the what? Integral of g of x times what?
f prime of x
F prime of x
dx.
dx. Cool? Now, that's hard to remember. So what we do is, in calc, we come up with letters U's and V's to make this easier to memorize, just to remember. So we're gonna let's go over here. Let's let F be the letter U. Let's let G be the letter V. So this means the integral of any U, that would be what? dv? We can say g prime of x dx, it's just a dv.
Yeah.
Will always equal, here comes the formula. U v minus integral v du.
D, okay.
And this is the formula that you want to memorize. And so everyone in calculus goes uv minus integral v du.
I'm gonna do that right there.
Now we're going to work a problem, and I want to do our x e to the x one.
Okay.
Will that work?
Yeah.
So we're going to use this to integrate x e to the x. But there's a formula, let me put it over here. It's called the integration by
Product.
parts. It's the opposite of product
Right.
rule. And we're saying the integral of a u, where is it? u dv will always equal u v minus integral v du. A lot of students say voodoo, like the word voodoo. Some say ultraviolet. They come up with different phrases like University of Virginia and all these other things. Just to help them remember.
Right.
You know, UV, University of Vermont. I've heard it all. I've heard it all. So now, let's have some fun.
So we can, between x and ex, we can take any one of them as u or v, or that's the,
Great question. You're going to learn from experience, but
uh-huh.
I'll tell you, through peer, you're going to go, what should I let u equal to in these problems? So everyone's going to have to let u equal something,
Uh-huh.
and then we're going to differentiate it.
Gotcha.
And then we're going to have to look at this. This formula is written as in terms of u and a what?
dv. Uh-huh.
So we're going to have to let u equal one part of this. Then we're going to have to let the other part be the dv.
Uh-huh.
So let me put u equals, I'm going to put a box. And then over here, I'm going to put dv equals a box.
Gotcha.
Now what I want you to do is, once we figure out what to let u and v equal something, u and dv equal something, we're going to differentiate that
Uh-huh.
to get a du. We're going to
Integrate.
integrate that.
I remember this.
Oh, he got it. All right, so watch this. Now ours like, what should I let u equal to? I want to tell you if it's got like x e to the x, x sine of x, x cosine of x, x times tangent, anything like that, let u be the x.
I had Kapoor for Calc 2.
Oh, you did?
Kapoor, yeah. So he's like really good with this stuff.
Oh, cool. And you had him for Calc 2?
Yeah.
So you did Calc 1, Calc 2, then you came back to Calc 1, or?
Well, Calc 1 I took in high school, so I was just like, let's repeat.
Oh!
I'm taking Calc 2 next semester.
Oh, cool.
I've taken DVQ also.
Yeah, or now you're going to take it with him? Calc 2?
Calc 3?
I mean Calc 2.
No,
You take it with him?
I already took Calc 2.
So you wouldn't have to do it again?
No,
Oh, that's cool. That's awesome. Now, did you take it with him here or at UMBC?
over here.
Oh, that's cool. Good job. All right,
Who did
now,
you, who did you have?
he had Kapoor.
Oh,
See,
Rajma.
he had calculus in high school,
Okay.
so Dr. Kapoor, he went to his class. Calc 2.
It was easy though, I didn't mind it. It's just in high school for the AP exam, I got like a 3, so I was like, just repeat it over here. I'll get a better credit.
Good call.
Yeah.
That's smart. I got a 4.
But
You know, it's kind of mad I didn't get 5 as a high school senior.
I'm trying to go to College Park, but they don't get 3s, they only accept 4 and 5.
Yeah.
For the Calc.
I got a 4, and I was going to Notre Dame. I was like, nah, I didn't get a 5. But anyways, I got to Notre Dame. I'm like, wait a minute, you know what I'm gonna do? I'm like, now I'm getting my transcript for college. This is my first time at college. I'm gonna take Calc 1 again because it's gonna be not only an easy A. I better get an A. Number 2, I'm gonna be better at this stuff. And people go, well, you lose this semester. I don't care.
It doesn't matter. Yeah.
Smartest thing I ever did.
Right.
I had a stronger foundation. I saw all the stuff I didn't make sense of before. I worked like 3 sections ahead of the professor every day. You know, I was relaxed. It was my first time at college. It was the smartest thing I ever did. So I'm like you. I like that.
So that means he's getting an 8?
Yeah,
He's getting an
probably.
8?
Hey, what's true of u?
Just one.
And I'll put dx, right? All right, now dv's the other part, which was what?
E to the power x.
All right, now integrate that. You gotta integrate it.
So that should
What's the
be
integral of e
e
dx?
to the power x plus c.
Oh, and I'll put the dx with this, right? See, I'll put the ex ddx here. And the integral of e dx is just e dx.
We didn't put the c?
No.
We will in the end, you can.
Okay,
You would, when we're done, we'll do that.
okay,
Very good.
okay.
All right, so here we go. Ultraviolet minus the integral of voodoo, right? All right, u, v minus integral voodoo.
Okay.
U is,
Xex minus voodoo is ex and dx. Okay, so now
d, du. Good, now, what's the final answer?
xex minus ex plus c.
You got it?
Okay.
Now, I wanna let you know, if you had like, let's say like x sine of x, 5x cosine x, dx, dx, 3x e to the x. Notice there's no power difference. It's kinda obvious when you need integration by parts. Any of these. Trig functions, e to the x, you let u equal the x, you let u equal the 5x, you let u equal the 3x. Now, when do you not let u equal that? I'm gonna go on this side. If you got a natural log, or if you have an inverse tangent. If you have either of these or an arc sine, like this is what you're gonna let u equal to.
Oh, you don't let them to you
Yep.
too.
So all these, when you get this x sine of x, 5x cosine x, 3x e to the x, what do you let u equal to? Let u be the what? The x,
X.
or the 5x, or the 3x, or any of these. But if you get any that has a what?
Natural log.
Natural log, or an inverse trig function like arctan,
Uh-huh.
or arcsine, because we haven't figured out those antiderivatives yet. But you do it by integration by parts. So can we do one? Can we do that one?
Yeah, sure.
All right, here we go. So when this is gonna be ln of x, and let's see if we can do it. Remember, this is calc 2. Now, natural log, that's what I want you to let u be.
Okay.
U is,
Natural log.
then dv is just the dx.
Uh-huh.
All right, what's the derivative?
1 over x.
What's the integral of a 1?
X.
Good. Now, here we go. Ultraviolet minus integral v du. All right, roll it out. U.
Natural log x and x.
So I like to put the x in front. Is that okay with that?
Yeah.
Look, x, ln x, it looks better. Because ln x gets sloppy.
Yeah.
X ln of x minus integral of
V du.
X.
v.
And
what's
du is
du?
1 over x.
X is crossed out.
And I should have probably put a dx here, huh? And you're saying these what?
Cross out.
X is crossed out.
So I get an integral of 1. So let's see. What's x ln of x
Minus
minus
one.
the integral of a 1?
X minus X.
Yeah,
So-
minus x. So what's the answer?
X natural log x minus x plus c.
You got it. And you'll probably get sick of doing this every time. You probably just memorize it. You'll probably just go, integral of ln of x is x ln of x minus x plus c. Kind of like, do you have it memorized already? What's the integral of tangent of x from today? You might have it memorized. It had an ln in it.
I forgot.
You probably eventually memorize it because you get tired of doing the use of every time.
Okay.
Do you remember it was secant of x or negative ln cosine of
Yeah.
x? We're doing integration by parts. Do you like it?
Alright.
She's not
Any
taking care.
more? Any more? Do you want to do
No,
any more?
no, I mean, that's cool. We can do others too.
Oh, I gotta show you something. Sometimes you gotta do like a repetitive thing.
Uh-huh.
So, today we saw this. Do you all recall that?
Mm-hmm.
U sub, oh, we won't do it now. What did we let u equal to?
X squared.
X squared, right? All right. When we did x e to the x, I can't put that on your test, Cal, but we said integration by parts. Well, how about this guy? You go, what is that? It's an integration by parts, but you're gonna have to do how many rounds?
2.
2 rounds.
Huh.
I know, so you're gonna have to be careful.
You make u equal to x squared.
Yep, and then you do a whole thing, and you get the power to go down a little bit. You get this whole thing written out, and you get to this, and you go, oh, I gotta do another what? Integration by parts. Do you follow me? And it gets kind of annoying, actually. I don't like to do this so much, because like, I gotta do integration by parts again. Isn't that cool though?
Yeah, it's
Oh,
interesting.
yeah.
So
Very
yeah, it
interesting,
means, you could really do this, but boy, it would probably take a while. It would,
It'd be kind of long.
that's a couple pages of work. Cause you keep what?
50.
You keep trying to break it down, so you finally got the power to get down to the x, e to the x, as you do 5 rounds of integration. by
Remember I
parts.
was telling you about Sylvanus?
Yeah.
He does all this proof on this book. In
Really?
1800, he wrote that book, and he did all the proof. And he's like purchased a theoretical math. I mean, like he'll do all the proofs, like nothing like Larson or anything.
Spanish.
Hey, tomorrow,
Uh huh.
you know what we should do tomorrow?